Good evening, everyone, and welcome to the last session of today. My name's Andy Woffer, and I shall be covering an introduction to the Unimelion, SUSE's ECM on ARM. And for those that are curious as to what a Unimelion is, SUSE has the chameleon as its mascot, and ARM software engineering team have the unicorn. And this is a marriage of the two. So I'll cover the brief overview of our setup, and then an update on SUSE's ECM actually running on ARM, and maybe a demo. So for those that were at SUSECon in Munich in 23, this was the current status. Rancher Rancher server was kind of supported. It was a bit of a tech preview. Downstream clusters were supported. K3S was fully supported. Fleet was fully supported, and Longhorn was fully supported. But we'd only just started work on NeuVector. There was quite a large chunk of work needed to get vector scanning in there. There was no RKE2 available on ARM. Harvester, we'd only just started as well, the support there. We had a kind of flaky internal build that sort of worked-ish sometimes. And upstream KubeVirt was still missing ARM support, and there was no ARM images available for Elemental either. So fast forward to today. It kind of looks quite different now. Most of the stack is supported there. You'll see a little bit of an oddity. You've got Rancher supported, but also not supported. Bit of a Schrodinger's cat, in so much as we have complete downstream support is there, but there are a couple of node drivers still missing that's preventing it from being GA. Elemental fully supported, NeuVector fully supported, K3S is still supported, thankfully. RKE2 is now fully supported, Longhorn still supported, which is great. Fleet, fully supported still. Harvester is now fully functioning, supported-ish, if you ask nicely, maybe. And Rancher Desktop's also there, should you need anything. What is missing is, as I mentioned, the node drivers to enable GA for Rancher, but also crucially SUSE Observability. StackState's so much easier to say. So StackState's not there yet. We've only kind of just started the discussions on what's needed to get StackState supported in ARM. So what does the enterprise container management look like on ARM? This is kind of our architecture. And so, at the bottom we've got the edge IoT devices kind of running Elemental. We've got Harvester as our Virt platform. And we've got cloud providers, whether it be AWS, GCP, etc., all there. And our primary nodes tend to sit on AWS Cloud, and we've got GitLab and other services all plugging in there. So as you can see, all the various components there from the applications all managed by Fleet, it just works. There's no difference to running on ARM, whether it be any of the hyperscale cloud vendors, as it would be running on x86, which is great. So Rancher and Fleet, just waiting on those node drivers to get full GA support, but we've fully tested it and it does just work. But for SUSE's perspective, it needs to have the full suite, so all the node drivers available there. So we're working on that, so we can get that GA badge. The node and cluster driver support is getting there. So Harvester was recently made available upstream. We're working on getting all the public cloud clusters working around the missing node drivers. It's not a huge amount of work, but it does take a little bit of finessing. But we are using Ranch Around Fleet to fully manage our entire Kubernetes estate for our software division, and we've had near enough zero issues doing that. So it is well tested. We've got over 1,000 engineers now sitting on the system, and we're looking at growing that to 2,000 to 3,000 over the next couple of months. Harvester. So GA support is there for the 1.5 release. That GA support does not cover multi-architecture clusters. That is planned for the future. So if you want to have a heterogeneous cluster of x86 and ARM, you're going to have to wait a little bit for that support. The blocking issue related to ARM support has been with upstream KubeVirt, and we are working on addressing that. It's mostly there now. They now have ARM-based images available upstream, which was one of the last hurdles to overcome. With regards to Harvester, this has been one of the projects where ARM engineers and SUSE engineers have been collaborating on quite closely. This was very much a joint effort to actually get the ball rolling, get it working, get it tested, so much so that we are running the complete suite of tests to ensure that it all works on a reasonably sized cluster, because it's not necessarily something that either SUSE or upstream have access to. We use Harvester primarily for two use cases. Obviously, there's the private cloud hypervisor perspective from a Kubernetes standpoint, running SL Micro and RKE2, but we also use it for our developers, because as much as we love our developers and we think they're fantastic, we don't trust them. So we carve up chunks of resources that they need, and we go, okay, there you go. You have your own set of resources, however much CPU, however much memory, etc. You do what you need to do. Don't annoy us. Don't involve us. Merry Christmas. Have some fun. And it's completely contained. We can sit back and relax and not worry about them taking down half of production or whatever else. All's working, although our sysadmin team are petrified of the upgrade button. In-place upgrades are supposed to work. Everything is there. We're just too chicken to press the big red button. We'll wait until we've got some additional clusters in place before we try and test that to see whether it works or not. But it should work. I've been reliably told. So with regards to RKE2 and K3S, K3S has been well supported in ARM for what feels like many moons, and so that was never an issue. We kicked off our deployment using K3S, not RKE2, because the latter didn't have support at the time. And we've used K3S in anger against a variety of different workloads, whether it be data center based ones or edge based ones, and it just works. So we were quite happy running that. Once RKE2 support landed in 1.27, we start deploying that in anger, especially for most of the data center workloads. It does come with hardened images for multiple architectures. However, only the x86 Linux image is FIPS compliant, if that is of concern to you. We'll see if we can get the ARM images compliant. We are using RKE2 for both our cloud deployments as well as directly with Harvester as well. So it's, again, another well battle tested from our perspective, and it works reasonably well. NeuVector, again, this was another great collaboration from ARM and SUSE, and the two of us working together, we managed to get NeuVector support in 5.3.0. So we, on ARM, NeuVector uses VectorScan as the backend library, not Hyperscan, for multi-arch use cases. This is because Intel weren't accepting upstream patches, and regardless of the pleas from partners, from ARM, even offering engineering resources, they weren't willing to accept the patches. So we did, we pulled the trigger on the forking as a final option, and we created VectorScan out of that. But that tracks Hyperscan very closely and as full multiple architecture support there. And so, by tweaking that, and we had to change the container environment so that they could build for ARM64. We started deploying NeuVector by default into all of our clusters. Using vulnerability scans, runtime security, the process blocking, and network segmentation, we went for KubeWarden over NeuVector for the cluster policies, primarily from an ease of use and reuse for those policies. We love NeuVector. It's just a matter of using the right tool for the right task. And so if it fits for you, absolutely use NeuVector. It does work really, really well. It integrates perfectly with Rancher and allows us full transparency of the clusters. Longhorn, that's been around for quite a while as well. So version 1.4 was when ARM support landed for that. We've never used Longhorn outside of Harvester, but we do make extensive use of it from within Harvester for the VM root disks. And we do take advantage of the external storage class for a lot of the workload storage. So it allows us better scheduling of the volume replication and offloading large and hard to replicate volumes to dedicated storage like NetApp filers, etc. Elemental, it's now, that was functional in the development stage. We've tested it on Raspberry Pi 4s, the K3S. There are some minor issues on ARM, but overall it just worked fine. We did have to create the seed image for the Raspberry Pi. That was a bit of a manual task. And then we also had to build the operator for ARM. We're now looking at using Elemental to manage workloads on our entire board farm. So observability, as I mentioned, that was only announced last year. It doesn't work on ARM, and we've had discussions with the observability team to see how we can get the ARM support in there. So that's a TBD task at the moment. Turtles, the CAPI aspect is, looking at Kubernetes operator to provide the integration. And we had to build the Turtles container and install it from our own private registry. That wasn't available publicly, so we had to handcraft and massage it. We've been able to provision RKE2 clusters on Harvester using Cap RKE2 and Cap HV providers. The CAPI was less flexible than provisioning EKS clusters with Terraform and importing them, but it's relatively new still, so we chose the cluster templates via Fleet or Terraform as an alternative. We are looking at standardizing completely on all aspects of the ECM stack, just to make our life easier, and primarily it's the one throat to choke aspect that gives management that fuzzy feeling inside. QA side of it, so we've started collaborating with SUSE to run the entire suite against each GCM component on ARM, as I mentioned earlier. We've started with Rancher, with RKE2, K3S, and Harvester, because they're the big ticket items for us that we absolutely don't want to be without. So that's what we're starting, and we're going to move down the stack as well. We'll be updating the tests where possible to ensure that there are ARM64 targets. And we're hoping to add the suites to our internal CI/CD pipelines, not only to validate contributions to the larger components, but upgrades to our existing infrastructure. As a bonus, we've got SUSE Manager. No, it's not part of ECM. We know that, but we've had Manager now for a number of years, and it kind of predates our Rancher deployment, and the team love it. So it continues to play a vital role in our deployment. It's been fully supported on ARM since the 5.0 release, and we use it primarily to manage our private cloud estate, provisioning the Harvester clusters, the whole life cycle management of Harvester nodes, etc. If you need to net boot and patch things, it is the tool as far as our teams are concerned. They find it to be far superior than many of the other products out there, and for them, it just works. So do give it a go. So, demo time. Unfortunately, the gods are angry. I do apologize. I did try. I spent 2 hours earlier today, and it's not you, it's me is the issue. We've had a number of weird connection issues remotely, and trying to, from security policy perspective, it was just too much. So I didn't sacrifice enough bunny rabbits or kittens, so I'm ever so sorry. But next time I'll make sure I've got a nice herd of cats to offer to the gods. And with that, thank you.